Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 14B assignment. Okay, so first one, number one here, state whether each of the following is a valid probability distribution. So, two things have to be true for it to be a valid probability distribution. All these probabilities have to be between and including 0 and 1. And then also, they have to all add up to equal exactly 1. So first off, all of those are between and including 0 and 1, so it checks off the first part, and then we just have to add these all up. 0.2 plus 0.3 plus 0.4 plus 0.2. Add those all up. 4, 5, 6, 7, 8, 9, 10, 11. That's equals 1.1, so it's not a valid probability distribution. Let's just go with not valid. Okay, because of the 1.1. All right. For part 2, it doesn't even fulfill the first one because this here you can't have a negative probability of something happen, or you can't also have a probability of something more than one happening. Okay, so because of that, this one also is not valid. Okay. All right, let's take a look at number 3. Consider the probability distribution alongside. Find the value of A. So for part A, we know that all of these have to add up to 1. So 0.1 plus 0.25 plus 0.45 plus A all has to equal 1. So let's add these up. That's 0.7.8. So 0.8 plus A equals 1, so we can subtract 0.8 from both sides and get that A has to equal 0.2. Okay. For part B, is X a uniform discrete random variable? Explain your answer. And no, they're not, because they're not all the exact same number. If all of these were 0.25s, 0.25, 0.25, 0.25, 0.25, then it would be uniform. Uniform means all the probabilities have to be the same. So no, and the reason why is because not all probabilities are equal. Okay. Let's do part C here. State the mode for the distribution. Mode is the most often occurring, or the biggest, highest probability, so that's going to be this one right here. So that's going to be 2. And then for part D, find the probability that X is greater than or equal to 2. So probability that X is greater than or equal to 2 is going to be these two together, right? So that's going to be 0.45, and then we figured out that A was 0.2. So the probability of X being greater than or equal to 2 is going to equal 0.65. Okay? All right, next one to take a look at is number 6. So let X be the result when the spinner alongside is spun. Part A says display the probability distribution of X in a table. Okay, so the 4 possible outcomes are 1, 2, 3, and 4. So let's do this. So we're going to just do, say, X, right? Oops, that's pretty bad. Let's try that again. There we go. And then we've got, we know that we can get 1, 2, 3, or 4. Okay, so there are 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. 1, 2, 3 of those 8 will give us a 1, right? And 2 of those 8, or 1/4, give us 2, and then 3, there's only 1 of those 8, and then for 4, it's 2 of the 8, which again is also 1/4. Okay, so you can leave it just as like 3/8, 2/8, 1/8, 2/8. You can reduce it to 1/4. You can turn these into decimals. Whichever way you want to write it is totally fine. Okay. Part B, graph the probability distribution. So really all that's asking us to do is just make a little graph here. And then we're going to do 1, 2, 3, and 4. And then up here we'll just do, say, 1/8, 2/8, 3/8, and we don't even have up to 4/8, so we can just do that. And then really what I'm going to do, just to make it a little bit easier for us, we'll just make little dotted lines. You don't have to do this, but it'll just make it a little bit easier when we're drawing our graph here. Okay, so 1 goes all the way up to 3/8, so that goes like this. Something like that. 2 is 2/8, so that goes up to here. 3 is 1/8, and 4 is 2/8. So that's what our graph should look, something like that. Okay. Part C, find the mode and median of the distribution. Okay, so remember, mode is the one that is most often. So mode, in this case here, is going to be our highest probability, which is going to be 1, right? And now the median, what you got to do for that, you got to figure out which one of these is included right at the 50% mark. So let's see, 3/8. If we add 2/8 to that, that gives us 5/8. So somewhere right in here is going to be where the median is. That's going to be right in the, that's going to be the 50th percentile is the median. So you want to find where the halfway point of the data would be. Okay, you could also find it by going backwards. 1/4, well, it's 2/8 plus 1/8 is another 3/8 plus 2/8. It's got to be somewhere in here in 2. Okay, and then D, find the probability that X is greater than or equal to 3. Probability, sorry, less than or equal to 3. That's going to be less than or equal to 3. That's going to be the 3/8 plus the 2/8 plus the 1/8, which gives us 6/8, which is just fine. Or you could write it as 3/4, or you could also write it as 0.75. 3/4 or 0.75, whichever one you prefer. Okay? All right, moving on to number 8. A group of 25 basketballers took shots from a free throw line until they scored a goal. 12 of the players only needed 1 shot. 7 players took 2 shots. 2 players took 3 shots, and the rest took 4 shots. Let X be the number of shots a randomly selected player needs to score a goal. State the possible values of X. Okay, so A, let's see, it was 1, 2, 3, or 4 for A, right? And then what we want to do for B is construct a probability table. So that's where we're going to do this here, and we're going to do, let's say this is going to be our X here, right? So this will be the probability of X equaling X, capital X equaling little x. Doesn't, not terribly important at this point. So this would be 1, 2, 3, or 4. Okay, so we know that there's 25 total. 12 of the 25 players needed 1 shot, so I'm going to do 12 over 25. And you can, again, come up with a decimal if you want, or just leave it as a fraction. For 2, let's see, that was 7 players took 2 shots, so 7 out of the 25. 2 players took 3 shots, so 2 out of 25. And it says the rest took 4 shots. So we've got 12 plus 7 plus 2 is what? 12, 19, that's 21. So the other 4 out of the 25 took 4 shots. Okay, so again, you can leave it like that, or you can go through and give it as a decimal, but this is just fine. Okay? All right. Moving on to number 9. Show that the following are valid probability mass functions. Probability of x equals x plus 1 over 10 for x equals 0, 1, 2, and 3. So really what we want to do is we just want to plug each of those numbers in right there. So we can even do this 0. We can make ourselves a little table here. Here's, oops, that's not very straight. Well, it was straight, but just crooked. X, and then probability of x equals x. So we can do 0, 1, 2, and 3, right? So if we plug 1 in, 1 plus 1 is 2, 2 over 10. So I'm just going to leave them all as I'm not going to simplify my fractions because I think it's going to make it easier for me to add them up later. So I put, oh, sorry, I put 1 in. So that one there is 2 out of 10. If I put 0 in, 0 plus 1 over 10 is 1 out of 10. If I put 2 in, 2 plus 1 is 3 over 10. And I put 3 in, 3 plus 1 is 4 over 10. Okay? So now show that these are valid. So then we would have to just do 1/10 plus 2/10 plus 3/10 plus 4/10. So if we add those all up, 4, 5, 6, 7, 8, 9, 10, that equals 10 out of 10, which equals 1. So yep, that is valid. Okay? All right, last one to take a look at here is number 10. Find k for the following probability mass functions. Okay, so let's do this. First off, that's not supposed to be there. Let's make ourselves a little table here. And we've got x, and then we'll have 1, 2, and 3. Right? So let's make ourselves a little table, see if that will help us get it all figured out. So probability of x equals x here. So if we plug 1 in, we get 3. Well, we get 1 plus 2 is 3. 3 times k, that's 3k. If we plug in 2, 2 plus 2 is 4. 4 times k is 4k. And we plug in 3. 3 plus 2 is 5. 5 times k is 5k. And it says find k for the following probability mass functions. So you know if we add these all up together, 3k plus 4k plus 5k, we know that has to equal 1, right? So 3k plus 4k is 7 plus 5. We got 12k equals 1. So to figure out what k is, we simply divide both sides by 12. K has to equal 1/12. Okay? Okay. That's all we have for the 14B assignment. If you have any further questions on this or the rest of the assignment, please feel free to ask. Thanks.